right, so let's talk about one more example in terms of the breakdown of the octet rule with radicals. Let's think about molecular oxygen. So let's go ahead and quickly draw this Lewis structure. We have O2. The second thing we need to do is figure out valence electrons. 6 plus 6, so we would expect to see 12. For a complete octet, we would need 8 electrons each, so 16. So in terms of bonding electrons, what we will need is what we have is 4 bonding electrons. So we can go ahead and fill those in as a double bond between the 2 oxygens. So what we end up having left, and this would be step 6 then, because 5 was just filling in that, is 12 minus 4. So we have 8 lone pair electrons left. So we can just fill it in to our oxygens like this. All right, so using everything we've learned about Lewis structures, we here have the structure of molecular oxygen. And I just want to point out, for anyone that gets confused, when we talk about oxygen as an atom, that's O, but molecular oxygen is actually O2. The same for molecular hydrogen, for example. All right, so let's look at what the actual Lewis structure is for molecular oxygen. And it turns out that actually we don't have a double bond. We have a single bond, and we have 2 radicals. And anytime we have 2 radicals, we talk about what's called a biradical. And while using this exception to the Lewis structure rule, to the octet rule, for odd numbers of valence electrons can clue us into the fact that we have a radical, there's really no way for us to use Lewis structures to predict when we have a biradical, right? Because we would just predict that we would get this Lewis structure here. So when I first introduced Lewis structures, I said these are great. They're really easy to use, and they work about 90% of the time. This falls into that 10% that Lewis structures don't work for us. It turns out in order to understand that this is the electron configuration for O2, we need to use something called molecular orbital theory. And just wait till next Wednesday, and we will tell you what that is, and we will, in fact, use it for oxygen. But until that point, I'll just tell you that molecular orbital theory takes into account quantum mechanics, which Lewis theory does not. So that's why, in fact, there are those 10% of cases that Lewis structures don't work for.